So today we will solve the Pumdet 2017 question, and which is the MSc entrance test for the Presidency University and especially for statistics. Now from question number 1, so starting from the question number 1, so in question number 1 we can see that we have given a random variable capital X, and under theta 1 and theta 2 we have two given priorities, okay, or set of priorities, and we are given two critical regions. So let's say W1, which is x equal to 1 or 2, and W2, which is x equal to 3. Okay, now if we see the options, we just have to find which is not true. Okay, so if we see the options, we can see that which is not true. We have to find the option which is not true. So we can verify those options. First of all, so let the size of W1, so it will be priority under H0, x equal to 1 and 2. So that means we know that the priority of rejection of the null hypothesis under H0 gives the size. So priority under H0, x equal to 1 plus priority under H0, x equal to 2. And from this table we can see that so priority under H0, that means priority under theta equal to theta 1. So as we can see that we have to test the hypothesis H0 such that theta equal to theta 1 against theta equal to theta 2. Okay, so we concentrate on theta equal to theta 1 only. Okay, so if theta equal to theta 1, then under H0 x equal to 1 takes the value this 0.01. okay, and x equal to 2 takes the value 0.04. 01 plus 0.04. okay, and which is equal to 0.05. so this is the size of W1. So now size of W2 will be priority under H0, x equal to 3. okay, so under H0 means, you can see that under H0 means if theta equal to theta 1. So if theta equal to theta 1, in the left side we can see that the value will be 0.05. so it will be exactly 0.05. so the size of W1 and size of W2 are equal. Okay, so the option A is correct, but we have to find the option which is not true, but the correct option here is A. Next, option B. Next, for option B, so we have to check the power of the tests. So that means W1, so power of W1, let's say, so equal to priority of x equal to 1 and x equal to 2, or let's say x equal to 1 and 2 under H1. So under H1 means theta equal to 2, okay, or theta equal to theta 2. So under H1 theta equal to theta 2, so we can see that x equal to 1 and 2 will be the values x equal to 1 plus priority under H1, x equal to 2. okay, so from the left side we can see that under theta equal to theta 2, x equal to 1 will have the value 0.8 and x equal to 2 0.1. so 0.8 plus 0.1, and which is 0.9. so this is the power of W1, and power of W2 will be priority under H1, x equal to 3, and which is priority under theta equal to theta 2, x equal to 3. okay, now from the left hand side we can see that if theta equal to theta 2, x equal to 3 will be 0.04. okay, so it will be 0.04, and which is the power of W1. okay, so now we can verify that the power of W1, so this is 0.04 is the power of W2, so we can verify that power of W1 is much more greater than power of W2. okay, so W1 is more powerful. So option D is true. Okay, but we have to find the option which is not true. Now we can verify the option C. In option C, we just have to check the power is greater than size or not. Okay, so power of W1 is greater than size of W1. As we can see that power of W1 is 0.0, so 0.9, and size of W1 is 0.05. Okay, so obviously 0.9 is greater than 0.05, and hence W1 is unbiased, and power of W2 is less than size of W2. And if power is less than size, that is power of W2 is 0.04, and power and size of W2 is 0.05. Okay, so obviously 0.04 is less than 0.05. So that means W2 is biased. As we know that power, if power is less than size, then the test will be biased. So W2 is biased. Okay, so option C is also true, as in option C we can see that W1 is unbiased. So in option C we can see that W1 is unbiased, whereas W2 is biased. Okay, so obviously option C is also true. Now, so A, C and D, everything is true, and we can verify option B, which is not true, as option B said that W1 and W2 are unbiased. So obviously both are not unbiased. One is unbiased and another one is biased. So option B is not true. Okay, so the correct option for the answer, or for number 1, is option B. So we can see that option B is not true. So we know that Sn by n will periodic converge to P. Okay, and this is true by weak law of large number. Okay, you can see that Sn by n, in our question we can define Sn by n equal to, let's say, y, which periodic convergence to small p. Okay, and this is true for sufficiently large n. Okay, so hence for epsilon greater than 0, probability of mod of y minus p greater than epsilon will tends to 0 for sufficiently large n. So obviously this is true. Now in our problem, so if we concentrate in our problem, so in our problem, in this expression of y, we can see that y equal to 1 by 500. That means in our problem, small n equal to 500. Okay, and epsilon is 0.01. Okay, so we can see from this expression that epsilon is 0.01. So epsilon is positive and small n is sufficiently large. So we can say that alpha equal to probability of mod of y minus p would be greater than epsilon, and this will be tends to 0, and this is true for all p or for any p. Okay, so option D will be the correct option for number 2. So let's go to question number 3. So in question number 3, we have given x1 follows uniform 0, theta, and x2 follows uniform 0, 1 plus theta. So then by factorization criterion, So we can see that, or we can verify that, if fx curl is the joint distribution of, let's say, x1, x2, xn or something like that, can be written as g of tx curl and theta, where g of tx curl and theta is the function of x curl and theta, and hx curl is the only function of x curl. So hx curl is independent of the parameter theta. Then this tx curl would be sufficient, or will be sufficient for theta. Okay, and this is true by the factorization criterion. Okay, so now we will verify for this example. So as we can see that x1 is defined on 0 to theta and x2 is defined on uniform 0 to 1 plus theta. So we can verify x1 is defined if 0 less than x1 less than theta, or we can say that theta greater than x1. Okay, so let's say this is equation 1, and x2 is defined if 0 less than x2 less than 1 plus theta, and that implies theta greater than x2 minus 1, and let's say this is option 2. Now from option 1 and option 2 we can say that, so from option 1 theta is greater than x1, and from option 2 theta is greater than x2 minus 1. So from 1 and 2 we can say that theta is greater than max or maximum of x1 and x2 minus 1. Okay, now if we take the joint distribution of x1 and x2, so now let's the joint distribution of x1 and x2, so it will be like 1 by theta into theta plus 1. So as 1 by theta and 1 by theta plus 1 be the corresponding PDFs. Okay, and 1 by theta is defined if we take this type of indicator variable, and we will define the indicator variable later, and 1 by theta plus 1 is defined if we take this type of indicator variable. Okay, where 𝐈𝐴 b, or let's say indicator variable, so let's define like this. So 𝐼𝐴 comma b can be defined as 1 and 0 if a greater than b and otherwise. Okay, so obviously I theta comma x1 will be 1 if theta greater than x1, and I theta comma x2 minus 1 will be 1 if theta greater than x2 minus 1. Okay, so now combining these two. Okay, so as we know that the options or the conditions on indicator function, so indicator function will give both the 1 values if I theta max of x1 and x2 minus 1. Okay, that is if theta greater than max of x1 and x2 minus 1. Okay, so now if we apply the factorization criterion here, so it can be written as g of t of x1 x2 comma theta into hx curl. Okay, where, so let's say t of x1 x2 equal to max of x1 and x2 minus 1, and hx curl equal to basically 1. Okay, so we can say that tx curl or t of x1 x2, which is max of x1 comma x2 minus 1, will be sufficient for theta. Okay, or will be a sufficient statistic for theta. So option C is the correct option. As we can see that in option C we have given the maximum of x1 and x2 minus 1. So hence t equal to max of x1 and x2 minus 1 is sufficient. For theta. So let's go to the next problem, question number 4. Now in question number 4, we can see that we have given two distribution or two random variable having one having normal 0 comma sigma square and another one having exponential distribution with mean 2 sigma square, and both are independent of each other. Okay, so we can take the joint distribution as we have to calculate the UMP test. So we can take the joint distribution now. Let's start with question number 2. Okay, so in question number 2, we can see that we have given xi equal to 1 and 0 with probability p and with priority 1 minus p. Okay, and this is true for all I running from 1 to up to infinity. So that is, we can say that xi's follows, and every xi's are IID. So we have claimed that every xi's are IID. So you can see that this IID option. So every xi's are IID. Okay, so xi's are IID, Bernoulli, P. Okay, and this is true for all I. So then Sn, so let's define Sn equal to summation over xi, I running from 1 to n. It will follow, as we know that it will follow binomial n comma p, so on. Okay, now we have to test h0 such that sigma square equal to 1 against h1 such that sigma square equal to sigma naught square and which is greater than 1. Okay, so which is greater than 1. Now by NP lemma, so if we apply the NP lemma, so now by, so let's say NP lemma, so if we just simplify this, 1 by sigma naught cube e to the power minus x square plus y, so if we take x square plus y as common or by 2, then we will get 1 by sigma naught square minus 1. Okay, so as we can see that sigma naught square, so from this quantity sigma naught square is greater than 1, so 1 by sigma naught square must be less than 1. Okay, so this quantity must be negative, so this quantity must be negative. Okay, now from the concept of monotone likelihood ratio or MLR, we can say that if x square plus y, so hence we can say that, okay, so we can say that x square plus y, if x square plus y increases, then this quantity is negative, that means 1 by sigma naught square minus 1 is negative quantity, and x square plus y has a positive quantity before this quantity. So we can say that f1 by f0 is increasing in x square plus y. Okay, and we can see that the alternative hypothesis is sigma square greater than 1. Okay, so that means we can easily verify the option B, which says that UMP test rejects H0 when x square plus y is larger. Okay, so option B is the correct option. So now let's go to the next question. So question number 5. So in question number 5, we can see that we have a line, so let's say from 0 to 3 and here's a 4. Okay, so we have a random variable, let's say capital X, which can take any value or which can take any value in between 0 to 3, and we have a random variable, another random variable y, which can take any value in between 0 to 4, and x and y are independent. So we can say that x follows uniform 0, 3 and y follows uniform 0, 4 and obviously independently. Okay, now we have to find probability of capital X less than y. So now probability of capital X less than y. Now if we see graphically, then we can see that so let's say this is our y axis and this is our x axis, and the first quantity is defined from 0 to 3, and the second variable, so let's say this is x, and the second variable is defined on 0 to 4. Okay, so in this rectangle, now if x, we have to find the probability of capital X less than y. So if x equal to y, with a line goes through this point, and this is the intersection point, and this point is like 3.3, and this is 3.4. Okay, now probability of capital X less than y can be written as by double integration 0 less than x less than y less than 4, and 1 by 3 into 1 by 4 as x and y are independent, dx dy, and this will be equal to 1 by 12 into area of shaded region. Okay, now the shaded region, we can see that the shaded region is obviously a trapezium. Okay, so area of the trapezium means sum of the parallel sides. So the parallel sides are like this side and this side, so sum of the parallel sides, so half into sum of the parallel sides, that is 4 plus 1 into height. So this is the height. Okay, so height or the length between the, or the distance between two parallel sides, and which is 3. So into 3, and which is option A. So now start the next problem, question number 6. So as we have given that x1, x2, x3 and x4 follows IID normal 0, 1, and we have to find the option which is not true. Okay, so now from option A, we can verify that covariance between x1 plus x2 and x1 minus x2 is like variance of x1 minus, as covariance of x1 and x2 will be 0 as x1 x2 are independent, so minus variance of x2. Okay, and both are equal to 1, so 1 minus 1 will be 0, so they are independent. So option A is true, but we have to find which option is false or which option is not true. And from option B, x1 plus x2 by x3 plus x4, obviously x1 plus x2 is independent of x3 plus x4, as x1 x2 x3 x4 are independent of each other. So it can be written as, let's say, x1 plus x2 by root 2 and x3 plus x4 by root 2. Okay, and which is compared to normal 0, 1 by normal 0, 1, and obviously two independent normal 0, 1 ratio. Okay, and which will give Cauchy 0, 1. So option B is also true. Okay, and next option C, x1 square plus x2 square by root 2 and then the square, so x1 square plus x2 square, let's say by 2, by x3 square plus x4 square by 2. Now x1 square plus x2 square are function of x1 and x2, and x3 square plus x4 square are function of x3 and x4, and x1, x2 and x3, x4 are independent of each other, so obviously the denominator and the numerator parts are independent of each other. Okay, and these are equivalent to chi square. So let's say this is chi square 2 by 2 or by 2. Okay, so chi square 2 by 2, and which can be written as f of 2 comma 2. So option C is also correct, or option C is also true. Okay, so we have to find the option which is not true. So as the three options are true, we can say that the fourth option, which is, let's say, x1 by x2, x2 by x3, so the fourth option, so this option is not true, as all the options or all the other options are exactly true. Okay, so the fourth option is not true. So our correct option is option D. The next problem, question number 7. As in question number 7, we are given that x1, x2, xn follows IID Bernoulli variable. Okay, so IID Bernoulli variable. So let's say P with success priority P. So IID Bernoulli P. Now let y be defined as max of x1, x2, xn. Okay, so now we have to find the success priority of y. So success priority means priority of y equal to 1. Okay, now as you can see that priority of y equal to 1 means max of x1, x2, xn will be equal to 1. Okay, now x1, x2, xn, all the xi's, we can see that all the xi's takes only 0 and 1 values, only 0 and 1 values. Okay, so maximum of them is 1, that means at least one of them is 1. Okay, so max of x1, x2, xn is equal to 1, that will imply that at least one of them is 1. Okay, as if all of them are 0, then the max of them cannot be 0, max of them cannot be 1. Okay, so max of them is 1, that means at least one of them is 1. So priority of y equal to 1, that means priority of at least one of them is equal to 1. Okay, and which is equal to, so now we know that from the childhood that priority of at least one of them, that means 1 minus priority of none of them is 1. Okay, now none of them is 1 means all of them are 0. So 1 minus product over, as they are IID Bernoulli P, so they must be independent. So all of them are 0. And this is true for all the n events. So which will give 1 minus p whole to the power n. Okay, so the correct option will be option B. So as you can see that in option B, y is a Bernoulli random variable with success priority equal to 1 minus p whole to the power n. Okay, so obviously y is a Bernoulli random variable and with success priority this. Okay, now so if we just modify this problem as a note, so let's say we can say as a note that if we want to find the priority of y equal to 0, so as we have given the priorities or all the success priorities, but if we want to find priority of y equal to 0, that is the failure priority, so then priority of all 0, y equal to basically max of xi. So maximum of x1, x2, xn is 0, that means the maximum is 0, and xi takes only the 0 and 1 value, so the maximum is 0, that means all the xi's are 0. Okay, So all xi's are 0, and which is product over xi equal to 0 I running from 1 to n. So it will give 1 minus t to the power n. Or this can be calculated otherwise from probability of y equal to 1, as probability of y equal to 0 will be 1 minus probability of y equal to 1. Okay, so this will give the same result also. Okay, but individually if we want to calculate probability of y equal to 0, we can calculate in this way. Question number 8. Now in question number 8, we can see that we have to find the infimum of 2 to the power x plus 2 to the power 1 by x such that x is greater than 0. Okay, so as we know that, if we take two values, let's say a and b, a plus b by 2 must be greater than equal to root over ab, when obviously a and b are positive quantities. Okay, so a greater than 0 and b greater than 0. Now here 2 to the power x and 2 to the power 1 by x both are greater than 0, as x is greater than 0 and 2 to the power any quantity which can be positive or negative is always positive. Okay, so we can take a as 2 to the power x and b as 2 to the power 1 by x. So that implies 2 to the power x plus 2 to the power 1 by x by 2 will be greater than equal to 2 to the power 1 by x plus x, as we multiply 2 to the power x into 2 to the power 1 by x, so root over this quantity, and which is greater than equal to 2 to the power 2 the root. And how can we say that? So this is true. So let's say in a box, as x minus 1 whole square greater than equal to 0, so that means x square minus 2x plus 1 greater than equal to 0, and that will imply x plus 1 by x is greater than equal to 2. Okay, so we applied this relation here, that x plus 1 by x is greater than equal to 2. That means 2 to the power x plus 1 by x must be greater than equal to 2 to the power 2. Okay, so hence this, and this is equal to 2. Okay, or we have got that 2 to the power x plus 2 to the power 1 by x is greater than equal to 2 into 2, and which is equal to 4. Okay, so as we know that any set which has a lower bound and attaining the lower bound or attending the lower bound, that means the lower bound will be the infimum of that set. So 2 to the power x plus 2 to the power 1 by x is greater than equal to 4. So the infimum, so thus infimum will be 4. Okay, and infimum is attended if x equal to 1, then only equality occurs. Okay, and obviously x equal to 1, so this quantity, or x equal to 1, this value is a valid value or valid domain value, as we have defined the set as x greater than 0. Okay, or for x greater than 0. So obviously x equal to 1 satisfy this restriction, and the infimum value will be 4. Okay, so from the question we can see that option C, that the infimum is 4. So thus infimum equal to 4. So option C is the correct option. So we have solved 8 problems today. Okay, and the remaining problems will be solved in the next video. So stay tuned and subscribe the channel, and the question paper or the link of the question paper will be given in the description. So check the description to get the link for the question paper.